What can bleaching of coral reefs tell us about ocean circulation? Hello, friends. Jim here. Well, bleaching of coral reefs shows severe ocean circulation changes. And here we see a photo of a bleached Acropora palmata taken in Jamaica in 2023. You can see how white it is. That's bleached coral. And to give you the idea of the size, you got a scuba diver back here. A new paper in Oxford Open Climate Change indicates that extensive bleaching and deaths are widespread at several major coral reefs around the world. This suggests that climate change has resulted in shifting patterns in ocean circulation. Coral reefs may soon be a thing of the past. Let's not forget ocean acidification. As more and more CO2 goes into solution in the ocean, it lowers the pH. That leads to coral bleaching. That's also a major factor. Last year, 2023 was the hottest year in recorded history on land and in the oceans, with dramatic and unexpected temperature increases. The highest excess daily air temperatures recorded in 175 countries, as well as the most prolonged excessive sea surface temperatures, were centered around Jamaica. And 2023 marked the worst coral bleaching yet in the Northern Hemisphere, with the Southern Hemisphere poised to follow in early 2024. Probably referring to the Great Barrier Reef off Australia. Researchers have used hotspot analysis, defining hotspots as surface waters with excess temperatures more than 1 degree C above the average temperature of the warmest month at that site, as a predictor of coral bleaching. The paper is an application of the hotspot analysis on open access ocean temperature data from satellite observations. Areas of high 2023 coral bleaching mortality represent coral reefs included the entire Caribbean region, the east and west coast of Mexico and Central America, Kiribati, Fiji, Eastern New Guinea, which local observers report to have near total bleaching and severe coral reef death. The entire Caribbean region, both islands and continental coasts, suffered severe excess temperature, with the longest duration of abnormal heating in the Haiti, Jamaica, Nicaragua, Honduras, Costa Rica area, along with the west coast of Mexico and Central America. On a personal note, I spent a semester at the West Indies Laboratory located on the island of St. Croix, part of the U.S. Virgin Islands. So yeah, I spent a lot of time scuba diving around the reefs there and so forth. And to think that a lot of this has been damaged is quite disheartening. The paper examined the spatial patterns and temporal trends of coral bleaching, hotspot heat wave during 2023, considering their long-term changes to gain insight into changes in general ocean circulation and heat transport. Satellite sea surface temperatures are based on infrared emission from the sea surface. This is really important. Infrared emission from the sea surface. What is infrared emission from the sea surface? That's heat diffusing from the oceans to the atmosphere. Hello? And yet you've got people, when they calculate Earth's energy imbalance, they do not include that. They only look at what comes in, what reflects out, the top of the atmosphere, but they do not look at infrared emission from the sea surface. Which is also the heat that's diffusing from below the sea surface. It gets up there and it emits. The oceans have absorbed over 93% of our heat energy. That is a huge energy imbalance that's going to have to be accounted for. And atmospheric folks do not do so. Changes in sea surface temperature result from changes in heat transport from the atmosphere due to changing winds and waves, as well as horizontal changes in surface ocean currents, and vertical movement due to mixing of surface and deep water. Yes, glad to see that factor included. Vertical movement. Basically, the mesoscale eddies, they facilitate the mixing between the atmosphere and the ocean. Now, changes in sea surface temperature, changes in heat transport. Well, that's part of the story. You change the heat distribution, you're going to change the various atmospheric cells, you're going to change the temperature and pressure gradient, and therefore the strength of the winds, the wind direction, which then create a wind stress on the ocean's surface. Okay, so yeah, that might change the horizontal surface currents, as they correctly state here, but you need to include the role of mesoscale eddies in facilitating the mixing of surface and deep water. Although satellite sea surface temperature measurements provide instantaneous images only of two-dimensional surface heat distribution, regional changes in temperature can provide insight into changes in the global heat circulation patterns. Yes, we don't get the information from the satellite of what's the heat content in the ocean is at 500 meters down. Got to include that. The paper finds that all major warm currents show extreme warming during 2023, suggesting that heat transport from the tropics to the polar regions has accelerated. This is keeping the tropics relatively cool, making the heating greatest in subpolar oceans. Well, this is very interesting. Where you might see this not necessarily holding is the North Atlantic, because you got all that freshwater melt that's actually keeping, you got that, ice melts, right? You have all that melting ice, you got that freshwater input, that water is going to be, at 0 C. That's going to keep that region cooler. And we are seeing that at least in the lower Atlantic seaboard, eastern seaboard, things are getting a bit warmer, including the ocean. So that might not necessarily hold for the North Atlantic. But then again, you have heard me opine on my videos, on podcasts I've appeared on, that in the past, when we've had all this melting of the ice and all this freshwater dumping into the North Atlantic, that helped trigger or encourage the growth of ice sheets. I now think that this will simply lead to a regional cooling. So places such as Iceland, the UK islands, Scandinavia, those sort of regions. But in the North Pacific, that could be a different story. And it kind of is a different story, because we're seeing that warming water moving in through the Bering Strait into the Arctic Ocean. So that is quite, so we're already seeing that. Another thing that's been of to note is that the gyres have kind of shifted several degrees northward, especially the North Atlantic gyre and the North Atlantic current. That's the branch, that's the continuation of the Gulf Stream going eastward towards Africa, towards Portugal, Spain, and then eventually Africa, from which the North Atlantic drift, that goes towards the Norwegian Icelandic Sea. That's what's slowing down as AMOC slows down. That's what gives rise to AMOC. But now we're finding that this North Atlantic current is shifting northward, and that may lead to warmer, drier conditions for southern Europe. Northern Europe is probably going to experience cooler, perhaps wetter conditions. So, yeah, this is interesting, what they're saying here. The 2023 distribution of severe heat and bleaching follows both spatial patterns and historical trends, first shown from a baseline 1982 to 2001 trend analysis. Increased warming of both hot and cold ocean currents show that horizontal mixing of tropical heat to the poles is accelerating, and that vertical mixing with cold deep water is slowing down, which will cause sea surface temperature to increase even more rapidly, which leads to a rapid and increasing stratification of the oceans. Now again, I'm going to put that caveat about the North Atlantic. But we are seeing increased warming and the horizontal mixing tropical heat to the poles accelerating. What is the work of Rebecca Woodgate and her team? They're showing that the water entering through the Bering Strait into the Arctic Ocean is warmer and has a higher Sverdrup, higher volume. So there's one ramification of that. And we're not getting the cold deep water because if the surface waters are warmer, they're less dense. They're not dense enough to sink. So this is going to trap the warm water in the surface, going to increase the stratification, which will lead to decreased net primary productivity, and you may, in some locations, trap cold surface water at various high latitudes. Again, think North Atlantic. Coral reefs, the most vulnerable of all ecosystems, began to bleach and die from high temperatures starting in the 1980s. Most coral around the world has been killed. There's a very strong word. Has been killed, and survivors can't take more warming, says the paper's lead author, Thomas Goreau. The sudden rise in global temperature during 2023 further imperils coral reefs and indicates large-scale changes in ocean circulation are underway, causing positive feedback that amplify global warming, which are not included in IPCC models. I'm shocked. Note sarcasm. Things are afoot. And we're definitely seeing changes in vertical, horizontal ocean circulation. That's going to lead to, well, we're already seeing the coral reef ecosystem collapsing. It's going to lead to an overall oceanic collapse. Warming temperatures, increasing stratification, increasing acidification, decreasing net primary productivity, All these lead to major decreases in taxa, major decreases in species biodiversity, mass extinction events. Factor in plastic pollution, overharvesting of oceanic resources. Oceans are dying. You've heard me say this many times before. Not good. And remember, phytoplankton provide 50 to 80% of atmospheric oxygen. If they start dying off, we're in deep trouble. And it's all taking place right now. We'll talk soon.